Domain and range with graphs, notes, discrete and continuous. So today we're going to be discussing domain and range, and we're going to be doing some color coding. So please bear with me. This is the first time I've tried this electronically. First thing we'll talk about is the domain. Domain is all the X values, the set of all inputs. It's kind of what controls everything. It is the independent variable. We generally pick the X to plug in. And I will be color coding it with the yellow highlighter. The range, as opposed to the domain, which is all the X values, is all the Y values, or the set of all outputs. And it is the dependent variable. It depends on what the X value is. And to color code it, I will be using the pink, okay? So we will go down here and we were going to look at the continuous graph first. I kind of think of a continuous graph over here on the left as one you can draw the whole thing without lifting your pencil is the easiest way to describe it. So when we're looking at the domain, domain is our x-axis, which is the bottom right here. This is our x. You look at what is this graph covering. It's covering all the way from the 0 all the way over here to the 8. The range, which is your y values up here, is covering all the way from the 0 all the way up to the 10. Okay, so it's covering all those numbers in between. It's an infinite number of variables. So down here, it asks for a little clarification, and it says, all right, an open circle and a closed circle. So these are all solid, which means it's including them all. When you include them all, that is a closed circle. So the closed circle means that it is included. Okay, so it's going to be a less than equal to or a greater than equal to. It's going to include that equal to because it includes that number. An open circle or an open dot means it doesn't include it, and that's going to be your less than or your greater than sign. And we write these all as inequalities like this. They're always going to be set up like this for the most part, so you're almost always going to use the less than signs. Every so often when you have an infinity, it might change, but for most intents and purposes, we're going to use it like this. Then you have a discrete graph, and a discrete graph is a little different. A discrete graph is a series of dots, so you have to move your pencil to draw it. And you basically just say, okay, what would be all the X coordinates of all these dots? And so I just kind of highlight it down. What would be all the X coordinates? And you're only going to list it once. And then for the one above, what would be all the Y coordinates? See, all these would have the same height, the same Y value. And you'll see where it crosses those axes and just label them. But you always want to go from smallest to largest. So that is something to remember. Okay, you do not repeat them. You do not repeat the numbers even if they come up. Okay. And you're going to go from smallest to largest number. Okay, smallest to largest. And as a reminder, it's just taking those points. So it's those X, Y coordinates. Domain is the X and range is the Y. Okay. All right. The smallest to largest is also a key factor over here on the left. Okay, you'll notice it goes from the smaller number to the larger number. So you're always going to label them the same way. So now we're going to state the domain and range for each graph. I'm going to do the domain first, so I'm going to take my yellow highlighter and I'm going to look at the x-axis. And I notice that this goes from -4 all the way to +4. So I'm going to go down here and label that it goes from -4 to +4. It is solid dots, which means it includes them. And the domain is all of my X values. It's all my X values, and I apologize. I usually write that on there right away, and I forgot. Then I'm going to look at the range. Range is all my Y values. So I'm going to come over here, and I'm going to look at the lowest point first, and it goes from -3, and it's solid all the way up to +3. So it goes from -3 to +3. Okay, that is all my Y values, and it includes them all. Then it asks if this one is a function. So we're getting back to the old goodie. Is it a function? Yes or no? passes the vertical line test, so yes, it is a function. We would only touch it once. So now let's go over here and let's do our domain again. As a reminder, domain is all of our x values, and we're going to look at the domain. This one is my x-axis. It goes all the way from -3, but it doesn't include it. That is an open dot all the way over to +3. So I'm going to write my two numbers. It goes from -3 to +3. It's my x value. And it doesn't include either one of them because they're open dots. So that would just be the less than symbols. I'm going to go to my range, which is all of my y values. And this one goes at the lowest point to -5 all the way up to 3. So this one goes from -5 to 3. And it does not include them. So it's going to be a less than. So this one denotes a open dot, okay, and the less than equal to means a closed dot, or solid line is another way I like to describe it. Now we're going to have a couple of different things. We're going to look at a graph, and this is a really important graph right here. This is your quadratic functions right here. We're going to get into those next semester, but I thought it was important that we see it now. We look at the domain and range because the domain is always the same thing. So first I'm going to look at my domain, which is all of my x values. Okay. And I notice that this arrow means it just kind of goes on forever. So negative forever is technically negative infinity. But then I notice to the right it also goes on forever, and that's considered positive infinity. So the domain actually on this one is from negative infinity to positive infinity. Now let's talk about open versus closed dot. I like to explain it as we can never contain infinity. So it will never be equal to infinity because we can never equal infinity. The range is a little bit different. The range is always going to have a lowest or highest point. And on this one, as you can see, it has a lowest point of 0. And it goes all the way up. Those arrows are going to go forever to infinity and beyond. So this one actually goes from 0 to infinity. And it includes the 0 because the 0 is solid, so that will be included, but we can never include infinity. The other way you might sometimes see this one written is you'll notice it just takes this little part out. So you'll notice when you flip it, we discussed this a lot, it's eating the y, it continues. So y is greater than or equal to 0, and that makes sense because it goes up forever. Over here is a table, and we have to take the domain and range from the table. So I'm going to remind myself domain is all my x values, and you literally just list them in squiggly brackets. 4, 5, 6, 7. And then you're going to look again. Let me go ahead and highlight those for y'all because I didn't highlight them. Okay. Then you're going to highlight all of the range values, which are right here, and I don't want to cover them because they're kind of hard to read. But all of your range values are, in fact, all the y values. All you have to do is label them from smallest to largest, and that is it. This is discrete data. So then it's asking us both of these. Are they functions? Are they functions? Well, this one passes the vertical line test, so yes. On this one for a function, we just look at if the x's repeat. Do any of the x's repeat? I don't see any, so I'm going to say that yes, this is a function because that's all we're seeing of it right now. So that's all we can determine. So now we're going to go down and we have another table right here with some statements instead of just listing it. And then we have number 6, which is also going to be listing it. So right here on number 5, we're going to interpret this. So the first thing I'm going to do is I'm going to remind myself that domain is my x values. So I'm going to highlight wherever it says domain at. And then I'm going to remind myself that range is all of the y values. So there's my range questions, and then it asks about it being a function or not. So I'm going to come over here and I need to look at which one of these statements is true. And I'm going to highlight it with a different color. The domain is 2, 3, 4, 5. That is a true statement. The range is not that. The range is -24, -36, -48. So this one is in fact the range because this statement is not true. It is a function. Well, I'm going to look at my x values. They do not repeat, which means that it is a function. So those are just the 3 little pieces of information you need on that one. So now let's go over here and let's look at our domain and range again. Remember, domain is all my x values, and a point is x, comma, y. So to get my domain, I'm going to look at that first number in all of these. Now, what's hard about this one is listing it from smallest to largest. So if you guys mess that up, I'm not going to be super technical. If you just go in there and you label it as 0, 1, 1/2, 0.25, and 8, that is okay. The only thing is that an answer option will never have that. It'll put it in order. It'll be 0.25, 1/2, and then it'll go up from there. So just be cognizant of that. Make sure you're looking at the list as it's given. Now we're going to go on ahead and do our range. Our range is all of our y values, which is the second number. So I'm going to highlight all of them. If you have a yellow and pink highlighter, this would be a really great time to use it. And for this one, I'm going to go ahead and list it from smallest to largest. As I look at my numbers, I notice that 3/4 is the smallest, followed by 4, 6, and 9. And you'll notice I did not repeat 9. You do not repeat the numbers. Our last 2 examples are right down here, and they're both graphs. Okay, and number 7, I do like to discuss number 7 because basically it's going to go on forever, every which way. Okay, so we need to go on ahead and look at this. So I'm going to highlight first my domain, which is all of my x values, and I notice that my domain is going to go on forever, which is negative infinity, and it'll go on forever, which is positive infinity. So we will list that as negative infinity to positive infinity, and remember, you cannot contain it, so it's not equal to. You can never be equal to infinity. Now, as far as the range goes, the range, as y'all recall, is all of my y values, and you'll notice that the range goes, well, from negative infinity all the way up to forever, to infinity and beyond, okay? So this one is actually the same thing, okay? You can never contain it. This is our linear function, okay? A linear function is just a line that goes on forever in every direction. It never ends. And it is a linear function. It passes the vertical line test no matter where you draw that vertical line at. So it is a function. Number 8 is the one that students seem to have the toughest time with. So let's look at it first. I'm going to look at my domain values, which are all of my x values, correct? And I'm just going to draw my line down. -4, -2, there, and there. So all of my domain values are from smallest to largest, luckily they're in order here, is -4, -2, 1, and 3. So that's where those points, those are the x coordinates of all of those points. Now we're going to look at our range values. Our range values, I'll start at the bottom, is -2. Okay, that would be a -1. We're going to go up here. This will be +2, and this will be +3. So those are going to be all of your y values. So that's -2, -1, 2, and 3. Okay, and is this one a function? Does it pass the vertical line test? As a matter of fact, it does. We actually drew vertical lines with the domain, so this one is in fact a function.